Good day and welcome to today's class. Today's class is a continuation of our mathematics classes on SS1. In today's class, we shall be looking at the subtheme geometry. Geometry is a theme in mathematics for those in senior secondary. And in geometry, we have about 4 topics. So we shall begin with the first topic, which has to do with construction. So we shall take construction. Thereafter, we'll look at proofs of some basic theorems, trigonometric ratios, and then mensuration. We shall look at the objectives of basic geometrical construction. At the end of the class, students should be able to 1. Carry out the basic geometrical constructions. 2. Bisect any given line. Bisect any given line segments. 3. You should be able to construct given angles, including special angles. 4. You should be able to construct equivalent angles. And 5. You should be able to construct triangles given the required conditions. So at the end of this topic, these are the objectives that we tend to achieve. At the end of the class, you should be able to ask yourself, have I been able to achieve all of this? If yes, then we are good to go. Otherwise, we need to go back and revisit the videos and see how we can understand it by watching it over and over again. Before we continue, kindly like my videos as you watch. While I recommend that you subscribe to my channel and follow me on YouTube, on Facebook, if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. I also recommend that you share the link with your friends and families while you use the comment section to interact with me on areas that are still difficult for you to understand. Under the basic geometrical constructions, I say that all constructions begin with a point, and a point occupies a position but has no magnitude. A point is named by a capital letter. So in the course of this class, I'll be using words like point A, point P, point Q, point R, etc. These are giving you the location of a point. And this is how they are named. Also, let us also understand some terms that will be used. What do we mean by a line? A line is an infinite set of points forming a straight path extending in opposite directions. For example, I have defined, we said a point is a position that has no magnitude. So a line is said to be made up of points on a straight path that extends in both directions, both left and right. It means that a line has no end. So this is what we refer to as a point, as a line. That a line is a series of points. That a line is an infinite set of points forming a straight path extending in opposite directions. In short, we said a line is defined as the shortest distance between 2 points. So also you can define a line as the shortest distance between 2 points. While a line segment is a part of a line that has 2 endpoints and all the points of the line between them. If we have defined this to be a line, we then have it that from point L to M is said to be a line segment. Just like I said, a line segment is said to be a fraction or a piece of a straight line. So line LM is said to be a line segment. So it starts from L and M ends at M. So we say line segment, line MN, and line segment MN denoted by LM with a bar. Now this bar indicates that it is a line segment. beginning from L and ending at M. So this is how we represent a line segment. But for a line, you can just write it as line LM. But for a line segment, it is written as LM bar, which indicates that it is a line segment. So let's take some examples. Example 1 says we should construct a line segment PQ of length 4.7 centimeters. Some of the learning aids that will be required for this particular course includes a mathematical set. I think when you have a mathematical set, all that is required else you can find them in that mathematical set. A pair of compasses is there, your pencil and your rule. Then we have our measuring instruments like the protractor and your divider. So these are some of the teaching aid or learning aid that a student needs to have in um, performing better in this course. So how do we construct a line segment PQ of length 4.7 centimeters? Now you're asked to construct, okay? Now using a pair of compasses and a rule. Most students will just their form of the habit of drawing a line. All you need to do is just to measure, take your rule and you draw a line 4.7 centimeters. But in this course, I'm going to teach you how that can be constructed. Now, we have the procedures outlined here. Procedure 1 says, construct a line segment as follows. 1, draw a line of any length. For example, I have drawn this line. I didn't measure it, okay? So it is a straight line. We'll take it to be a line. Then, procedure 2 or step 2 says we should mark and label the point P. So pick a point, mostly at your left, okay? Pick a point, name it P. Step 3 says with a pair of compasses, measure out 4.7 centimeters. Now, the compass you find in your mathematical set has 2 legs. One is longer than the other. One has a sharp edge, okay? And the other is halfway down the other, holding a smaller pencil. So all you need to do is to position it in such a way that the pencil, when tightly fitted, is of equal length with the sharp edge. Once that is done, you now extend it, pick your rule. Let's assume this is a rule. Pick your rule, and with the point edge being at 0.0, extend the other edge to 4.7, either using the centimeter mark or the millimeter mark. If you're using the millimeter mark, then it goes to 470. But if you're using the centimeter mark, you stop at 4.7. Reason being that 10 millimeter make 1 centimeter. So 4.7 centimeters is equivalent to 407 millimeters. So once that is done, ensure that you tighten the edge of your compass, okay, so that the legs does not shake. So once that is done, hold it that way. Then with P as center, that's what step 4 is saying. With P as center, draw an arc to cut the line at Q. So with P as center, you put your point, the sharp edge at P, then the one that has a pencil, use it and construct and draw an arc. Where it cuts the line is said to be your point Q. So this point is said to be my point Q. And if you measure it, you discover that PQ is said to be 4.7 centimeters. So this is how you can construct a line segment PQ of length 4.7. It may be 4.7 or whichever you want to construct, but just note that in construction of lines, this is how to do it. So step 5 says the required line segment PQ is equals to 4.7, just like I have said. Kindly like my videos as you watch. While I recommend that you subscribe to my channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. While I recommend that you share the link with your friends and families so that they can also benefit from our daily classes. So let's move to example 2. In this next chapter, we shall be looking at construction of parallel lines. Before we look at construction of parallel lines, we need to understand, what do you understand by parallel lines? Two lines are said to be parallel when they never meet. Okay? When drawn, they never meet. They are said to be parallel lines. When they meet at any point, then they are not parallel lines. How do we know that they are parallel lines? They are parallel lines in the sense that the angles between the two lines are said to be 180 degrees. And they are said to be equidistant at any point. Example of a parallel line, if you look at, if this is your phone, this edge of the phone is said to be parallel with this. If you extend it upwards, they will never meet. Same thing with this, the horizontal plane, they can never meet. Okay? If you look at the lines in your exercise books, let me use this jotter as an example. If you look at the lines of this jotter, you will discover that they are said to be parallel lines because they can never meet. So these are examples of what we mean by parallel lines. The horizontal lines are said to be parallel. And we have so many examples. All right. So parallel lines lie side by side and can never meet or cross themselves. The distance between the lines remains the same at any point. Example 2, we are asked to construct a line segment PQ that is parallel to line segment AB on line CE, on line segment CE. So, how do we construct two lines that are said to be parallel? Let's look at the procedure. The procedure says, 1, we should draw the given line AB on the line CE. 2, with C as center, copy the angle BCD. Also, with D as center and the same radius as in step 2, construct angle QDE. Step 4 says angle QDE is equal to angle BCD. Therefore, line segment AB is parallel to line segment PQ. Now, how do we do this? I'm going to construct it for you. Now, if this is, let me call this line AB, I'm going to alter some of the marks points as given in the procedure. Now, this is line segment ABCD. If this is CD, and I'm asked to draw a line that is parallel to this, how do I do that? What the procedure is saying is that I should copy this angle. Remember, I said the angle between two parallel lines are said to be 180 degrees. So I'm going to copy this angle. The angle I'll copy here will be equal to the angle of the next parallel line. So how do I copy this angle? Now, with your protractor, for me to copy this angle, I'm going to draw a semicircle on this line CD. Now, if I call this MN, point MN, I'll also pick a point here. Let me call this point E. The radius I used in constructing this semicircle, MN, I'll also take it to point E. With E as center, I'll construct a semicircle, okay, with that same radius as MN. Now, how do I ensure that angle C, let me call this O, angle CON is equal to the required angle? Now, what I will do is I will pick my compass with N as center. I will copy out the angle on CDN. That is this way. With N as center, put your compass, okay, the pin edge on N, and then copy out, extend the other leg to be at point, let me call this Q. Okay, so with N as center, extend the other leg to get to Q. Now, once you have gotten that, don't adjust the compass again. Hold it with that same angle. Come to point P on this other side. With P as center, the pin edge should be on P. Then cut an arc on that semicircle, something like that, like this. Okay. Once that is done, you are to name that place. Let's call that point R. Now, when you join, draw a line through ER, and that gives you the required parallel line. Mine is a freehand sketch, so you may not get it accurately. Okay, so let's call this line ST. So if this angle is said to be 60 degrees, for example, this is also said to be 60 degrees. And by that, you have it that line segment CD is said to be parallel to line segment ST. So this is how you can draw two parallel lines together. Kindly like my videos as you watch. While I recommend that you subscribe to my channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. While I recommend that you share the link with your friends and families so that they can also benefit from our daily classes. Next, we are going to look at construction of a perpendicular line. Construction of a perpendicular line. A perpendicular line is a line which meets a given line at right angle, or the angle between the two straight lines is 90 degrees. That is what we refer to as a perpendicular line. Now, if you have a horizontal line and a vertical line in this point, we can say that these two lines are said to be perpendicular because the angle formed, which is this angle, is said to be angle 90 degrees. So if you have two lines meeting at a point or meeting at just one point where the angle between both of them are said to be 90 degrees or is said to be 90 degrees, such lines are said to be perpendicular lines. So how do we construct a perpendicular line? Step one, that a perpendicular from a given point to a given straight line. So those perpendicular lines may come in different forms. One may be a perpendicular line from a given point to a straight line. You may be asked to construct a perpendicular line from a given point to a straight line. For example, if this is said to be the point, this is said to be the straight line AB. You may be asked to construct a perpendicular line. So this can be the perpendicular line with the angle between them being said to be 90 degrees. Given that a point and a straight line AB, as I have said, that to construct perpendicular bisector of the segment AB from a point P outside AB. So the point may be outside of AB or maybe in between AB. So one of the aspects of a perpendicular line from a point may be to construct it from a point outside of AB. For example, this is point AB. This is the line AB with your point P, and we are asked to construct a perpendicular bisector of the segment AB from a point P outside AB. Now, what that means is perpendicular bisector means that such a line or such a line is dividing AB into two equal parts. That is what we meant by a bisector. A bisector is a line that divides either an object or a line or an angle into two equal parts. So, how do we construct that? Construction. Step one says From point P, draw an arc to cross AB at C and D. Now, what that means is get your compass, okay, extend it to a given radius. Then with P as center, you construct an arc this way and this way. So it gives you point C and point D on the line AB. Then step 2 says with C as center and with radius greater than half of AB, draw an arc below line AB. Now, with C as center and a radius greater than half of the line CD, you construct an arc below the line CD. So if you do that, you may get something like this. So it will give you something like this. Also with D as center and with radius greater than half of the line, you also do same. Now, most times you may decide to, at this point, you can extend, you can alter the radius and it will still give you the same answer. Okay, but for the sake of you being a learner, okay, just use the same radius, okay, and construct an arc below AB, and both lines or both arc are going to meet at a point. Now, that point, you can call it point Q. Now, with your rule, you will now join line point PQ, okay? When you use your rule, you have something like this. Now, because this is a freehand sketch, it will not be drawn to perfection. But when you are done doing this, you discover that the angle at this point will be said to be 90 degrees, or this point, or this point, or this point. Whichever you measure, they are all going to give you 90 degrees. And once that is done, you also discover that the distance between, let me call this M, the distance between C and M will be equal to the distance between M and D. Just like I said, a perpendicular bisector divides a line into two equal parts. So that is what we are asked to do. Step 4 says join PQ, and this is a line perpendicular from P to AB. So this is how you can construct a perpendicular line using a pair of compasses only. Kindly like my videos as you watch, while I recommend that you subscribe to my channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. While I recommend that you share the link with your friends and families so that they can also benefit from our daily classes. Let's take the other aspect of perpendicular lines. Now, this is to construct perpendicular bisector of line segment AB from a point P inside AB. Remember I said to construct a perpendicular line from a point, the point may be either outside of the line AB or in between the line AB. We have looked at the line being outside of AB, and in this next example, the line is said to be inside AB. Now, construction. How do we construct that? Step 1 says with P as center, draw an arc to cross line AB at C and D. So with that radius, put the sharp edge on P, construct an arc left way and right wing, and you have something like this. Now, that point, that arc are going to be equidistant from point P. So this should be point C, and point D. Step 2 says with center C and D, draw arcs of the same radius, which must be more than half of CD to meet Q above line AB or below line AB. So what you do is that with C and D as center and with radius greater than half of CD, you can now construct an arc above or below. If you do it both ways, it's still the same thing. Okay, so with C as center, construct an arc above AB. Now you have something like this. With D as center, you construct an arc, you have something like this. Okay, and if you do it downwards, you have something like this and like this. Then let's call this point Q, or this as point Q. You can tag it. Now you are to join line point PQ, either upwards or downwards, okay? Or you can join QQ, point QQ, okay? Or Q and Q prime. Let me call this Q prime, okay? Because they'll still form a straight line. So when you join these 2 points, it gives you an angle 90 degrees when measured using your protractor. And also, if you measure the distance from, let me call this point O, if you measure line CO or OD, they are said to be equal. So this is how you can construct a perpendicular bisector of line segment AB from a point P that is inside of AB. So join PQ and that gives you the required perpendicular bisector. Kindly like my videos as you watch. While I recommend that you subscribe to my channel if you are yet to do so, also follow me on my Facebook page at my lesson teacher Maths if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. While I recommend you share the link with your friends and families so that they can also benefit from our daily classes. Next is to construct a perpendicular bisector of a given straight line. Now there's no point. In the first 2 examples, we're given a point that one is in between the lines AB and the other one is said to be outside of these lines. But what if the point is not given? How do you bisect a line? Or how do you construct a perpendicular bisector? Remember, perpendicular in the sense that it is crossing the line AB only at one point and is a bisector such that it is dividing that line AB into 2 equal parts. So how do we construct such a perpendicular bisector? We say a perpendicular bisector of a straight line which divide a given line into 2 equal parts and at right angle to the given line. From the question, all that is given is that it is a straight line AB. So if we have the straight line AB, how do we construct a perpendicular bisector to AB? Now, let's listen to the procedures or the steps. One is that with radius more than half of AB, draw an arc from A with the same radius, draw an arc from B to cross the first arc at P and Q. Join P to Q, then line segment PQ is the required bisector of AB. Now, this is the line AB as given, and how do we bisect it? All we have read, I'm going to summarize it, that with A as center, pick an arc using your pair of compass, okay? With the sharp edge, with A as center, you construct an arc above and below the line AB. Do same using B as center without altering that radius. So with A as center, you have an arc like this. Just construct an arc above and below. You are not to draw the full circle, okay? Just an arc above and below. Do same with the second, with point B as center. Construct gives you this and this. Now name the upper part point P and the lower part as point Q. Now join point PQ. that gives you a perpendicular bisector of AB. So when you join this when measured is said to be angle 90 degrees. Either this is 90, this is also 90, this is 90, as well as this is 90. And if you measure, let's call this center point M, AM will be equal to BM. That is one of the features of a perpendicular bisector. So I say that, note that, okay, I use the middle part as R. So if this is R, note that AR is equal to BR and AP is equal to BP. That is, the distance from here to here is equal to the distance from here to here, from this to this, and also AQ will be equal to BQ. Okay, and we said that angle PRA is equal to angle PRB. Where is it? This is PRA, that is this angle which I said is what? 90 degrees. Kindly like my videos as you watch. While I recommend that you subscribe to my channel if you are yet to do so. Also, turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. While I recommend you share the link with your friends and families so that they can also benefit from our daily classes. We shall now take more exercises on construction. Next is for us to construct the bisector of an angle. I have shown you how to construct the bisector of a line in different aspects, be it a perpendicular line, how to draw a line, and in this next example, we shall be looking at how to construct the bisector of an angle. When an angle is given, how do you divide it into two equal parts is what we are looking at. So, procedure, step 1 says, draw the angle ABC of any size. So, one thing I love doing in construction is the moment I begin to read the procedure, I create a mental picture of what is expected of me to do. Otherwise, I can draw a sketch of it for easy understanding. And from that sketch, I can be able to construct it to scale. So, step 1 says we should draw the angle ABC of any size. So, let this be our angle ABC. If this is A, this is B, this is C. So, this is our angle ABC. Remember, in naming, the alphabet having the cap on its head or the heart is said to be the angle, where the angle falls, okay? And it's at B. So this is the angle ABC. Then with B as center, let's call this theta. With B as center, draw an arc to cross lines AB and BC at point A and C respectively. That is, with your compass, one leg on B, you are to construct an arc to cut AB and BC. So if you do that, this is what you get, something like this. And this point is the required point we are told, which is A at point A and C. So this is said to be point A and this is said to be point C. Step 3 says with A and C as centers, having the same radius, draw arcs to meet at D. So you can then extend or reduce the radius, but ensure that it is greater than half of the distance AC. So with A as center, construct an arc this way, and with C as center also, construct an arc this way. And that gives you a point D. So this is said to be our point D. Then the step 4 says you should join BD, and BD is the bisector of angle ABC. So when you join these points, B and D, it gives you the bisector of angle ABC. Now, if you measure this angle, it gives you theta over 2. And if you measure this, it's also said to be what? Theta over 2. Theta being the required angle that you drew. So, BD is said to be the bisector of angle. So, this is how to bisect a given angle. It may be an acute angle, reflex angle, angle 90 degrees, 180 degrees, or whatever angle. Even if it is angle 2 degrees, this procedure helps you to bisect it into 2 equal parts. Kindly like my videos as you watch. While I recommend that you subscribe to my channel if you are yet to do so. Also, turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. What I recommend you share the link with your friends and families so that they can also benefit from our daily classes. We shall now look at construction of some special angles. These angles are referred to as special angles because they can be constructed without the use of a protractor. That is to say, with your pair of compasses and ruler only, you can construct these angles. Now, one of them is angle 90 degrees, which I've shown you how to construct. That when you bisect a given line, it gives you an angle of 90 degrees. So, among the special angles, we have angle 60 degrees. 60 degrees said to be special angles, angle 45 degrees, angle 30 degrees, angle 75 degrees is also special, angle 120, 135, 150, angle 15 degrees, down to even angle 7.5 degrees. All these are said to be special angles because they can be constructed without the use of protractor. So we shall begin with construction of angle 60 degrees. Now, how can we construct angle 60 degrees? Procedure that we should draw a straight line of any length. So I'm going to be doing a freehand sketch of all these angles, but with the use of your protractor and with the right procedures or steps as I'm going to outline, you can easily do this. So step 1 says you should draw a straight line of any length, mark and label any point P on the draw line. So I will first of all take the procedure for 1 and 2, that we should draw a straight line of any length. So let's use this. This is a straight line of any length. Step 2 says mark and label any point P on the drawn line. So this is point P on the draw line. Step 3, that with P as center, draw a semicircle above the line to cross the drawn line at Q and R. So you extend your protractor with P as center, you then draw a semicircle. So this is going to be, let me draw this. Now your semicircle is going to be equidistant from point P. So this is Q and R. So let's assume it is the same. But since this is a freehand sketch, definitely you know it's going to give you something else. So I have done step 3. Step 4, that with Q or R as the center and with the same radius as in step 3, draw an arc to cross the semicircle in step 3 at S or T. So what that entails is this. You see that arc radius you use in constructing the semicircle, you are not to alter it. So with either Q or R as center, you draw an arc to cut that semicircle at a point. So if you are using Q with Q as center, when you draw a semicircle or an arc, it cuts it at this point. Whereas if you are to use R, when you draw a semicircle, it cuts it at this point. So that point where it divides it is said to be either point S or T. as the case may be. So we are asked to join PS or PT. So when you join P and S or PT, so when you draw this, it gives you something like this. Place this a freehand sketch, or you get something like this. Okay, so this angle now is said to be 60 degrees, or this is said to be 60 degrees. So we have it that angle QPS is 60 degrees, or angle RPT is 60 degrees. So let's say angle SPQ is equals to TPR is equals to 60 degrees. So this is said to be the required angle that you are asked to construct. So this is how to construct angle 60 degrees, which is one of the special angles I spoke about without the use of protractor, just with the use of your pair of compasses and rule only. Kindly like my videos as you watch. While I recommend that you subscribe to my channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. While I recommend you share the link with your friends and families so that they can also benefit from our daily classes. Another special angle I spoke about is angle 30 degrees. And how do we construct angle 30 degrees? I have shown you how to construct angle 60 degrees. Angle 30 degrees can be constructed by bisecting angle 60 degrees. I have shown you how to bisect a given angle and a given line. So when you bisect angle 60 degrees into two equal parts, it gives you angle 30 degrees. So to construct angle 30 degrees, you first of all construct angle 60 degrees as shown above, which I've already constructed. Step 2 is to bisect angle 60 degrees to obtain angle 30 degrees. So let's bisect angle 60 degrees. Now I'm going to consider the angle 60 degrees at my right hand side. So in order for me to bisect angle 60 degrees, as I have already shown you on how to bisect angles at the earlier on, all you need to do is with R and T as centers and radius greater than half the distance of RT, you are to construct an arc this way. Okay, so with T as center and radius greater than half of this radius greater than half of PT, you then construct an arc this way. Do same with R as center. You don't alter the radius. You also construct another arc. Then you call that angle, call that point. This is ST. Call that point U. With point U, you now join point PU. When you join that, you will discover that this and measure this angle is said to be 30 degrees, as well as this is also said to be 30 degrees. So that means that UPR is equal to UPT, which is equal to 30 degrees. So either of these two is said to be angle 30 degrees. That is how to bisect or construct angle 30 degrees. You first of all construct angle 60 degrees. You then bisect angle 60 degrees to give you angle 30 degrees. So I have it at note. You need to go back to how to bisect angles and follow the steps. Then also that angle RPQ, which is equal to 60 degrees, is bisected to give angle SPQ, which is equal to 30 degrees. Next is on how to construct angle 45 degrees. Angle 45 degrees can be constructed by bisecting angle 90 degrees. And how do we construct angle 90 degrees? All you need to do is to divide or is to bisect a horizontal line, and that gives you an angle 90 degrees. You therefore bisect angle 90 degrees to give you angle 45 degrees. So in order for us to bisect angle 45, to construct angle 45 degrees, the instruction says we draw a line segment AB and label a point P on the line. So if this is construction of angle 45 degrees, we first of all construct angle 90 degrees. The question says, the step says, we draw a line AB and label a point P on the line. So if this is the point AB, let me call it AB, pick a point and call it point P. Now, with center P and any radius less than both AP and BP, draw an arc to meet AP at X and another arc of the same radius and center P to meet BP at Y. So what that means is, with P as center and a radius which is less than the distance AP and BP, you construct an arc. So something like this and this, giving you point X and point Y. That is what the step 2 says. Then step 3 says, with center X and a radius greater than XP, draw an arc above the line segment AB, and with the same radius but center Y, draw another arc above line AB to meet the first arc at C. So what you do is, with X as center and a radius that is greater than XY, you draw an arc above, and with Y as center, you also draw an arc above. And when you join, let's call this point is called point C. So when you join P to C, it gives you a straight line which is said to be angle 90 degrees. So this is said to be our angle 90 degrees. Let's follow the steps and see. Now, having constructed angle 90 degrees, how do we bisect angle 90 degrees? With P as center, you draw an arc to cut line CP and line PY, and this gives you something like this. Call this M and N, this point as M and this point as N. With M and N as center and radius greater than half the distance, you construct an arc this way and this way with M and N as center, and let's call this point R. You now join point P and R together, and that gives you angle 45 degrees. So this is how you can construct angle 45 degrees. When you construct angle 45 degrees, also note that the corresponding obtuse angle is also said to be angle 135 degrees. That is to say that angle XPR is equal to 135 degrees when measured. Or you can say, since angle AB is said to be angle on a straight line, which is 180, when you subtract 45 from 180, it gives you an obtuse angle which is 135 degrees. So you can use this to either construct angle 45 degrees or angle 135 degrees. Same thing happens when we constructed angle 60 degrees. If this is said to be angle 60 degrees, then this other obtuse angle is said to be angle 180 minus 60, which is equals to angle 120 degrees. So by construction of angle 60 degrees, you can get either angle 60 degrees or angle 120 degrees on the other side. To construct angle 15 degrees, all we need do is to bisect angle 30 degrees, of which you know that before you get angle 30 degrees, you must first of all construct angle 60 degrees. So to construct angle 15 degrees, you should first of all construct angle 60 degrees. After constructing angle 60 degrees, step 2 is to bisect angle 60 degrees to get angle 30 degrees. And when you have gotten angle 30 degrees, by bisecting angle 60 degrees, you also bisect angle 30 degrees to get angle 45 degrees. That is how you can get angle 15 degrees. So if we go back to the bisection of angle 30 degrees, construction of angle 30 degrees, when you bisect angle 30 degrees, you get angle 15 degrees. Now, if this is angle 30 degrees, this is point R. If we call this point V at this point, with R and V as center and radius greater than VR, you construct an arc above and below. Call this point VX. Let me call this point X. When you join point P and point X, it gives us angle 15 degrees. So this is how you can construct angle 15 degrees by bisecting angle 30 degrees. And also, if you bisect angle 15 degrees, it gives you angle 7.5 degrees. So that is how you can also get angle 7.5 degrees, which is also a special angle. And by constructing angle 15 degrees, you also note that you have an obtuse angle at the other end, which is said to be angle 180 minus 15 degrees, and that gives us angle 165 degrees. So on the other side, you can get angle 165 degrees. Kindly like my videos as you watch. While I recommend that you subscribe to my channel if you are yet to do so, also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. Well, I recommend you to share the link with your friends and families so that they can also benefit from our daily classes. We shall then look at how to construct angle 75 degrees. Now, to construct angle 75 degrees is an angle that falls between angle 60 degrees and angle 90 degrees. If this is 60 degrees and this is 90 degrees, is said to be somewhere here. Okay, so if this is 90 degrees and this is 60 degrees, angle 75 is said to be in between 60 and 90 degrees. And if you look at angle 75 degrees, angle 75 degrees is said to be halfway between 90 and 60 degrees. So by bisecting the angle that falls between 90 and 60 degrees, which is 30 degrees, you can construct angle 75 degrees. So how do we do that? Let me call this point, this is X, Y, with Y and T as center, and radius greater than half the circle, radius greater than half the length, you construct an arc this way, and let me call it point Z. Join point P and Z, and it gives you angle 75 degrees. So this angle is said to be angle 75 degrees. And if this is said to be angle 75 degrees, which is an acute angle, it also leaves us with an obtuse angle the other way around, which is said to be angle 115 degrees. So that is how we can construct angle 75 degrees. But let's look at the procedure. That to construct 75 degrees, first you construct angle 90 degrees and 60 degrees. So when you have this is your 90 degrees, this is your 60 degrees. If this is 60 and this is 90, with this and this as center, you construct an arc this way. Joining these two gives you your angle 75 degrees, and the obtuse angle you get at this point is said to be angle 115 degrees. So you have to construct angles 90 and 60 degrees. Bisect the angle space between 90 degrees and 60 degrees. The angle between 90 degrees and 60 degrees is angle CPQ with center Z and Q and a radius greater than half ZQ. Draw two arcs to meet at R. Hence, RPB is equal to 75 degrees. Also, note that RPA is 115 degrees and RPQ is equal to 75 degrees. Sorry. So what we are saying in essence is that while this is 75 degrees, this is 105 degrees as the obtuse angle, because when you add both of them together, it gives you 180 degrees, which we said it is the angle at the point, because the sum of angles, sorry, which is said to be angles on a straight line, because the sum of angles on a straight line is said to be 180 degrees. So 105 degrees plus 75 degrees gives us 180 degrees. So for us to construct 120 degrees, 135 degrees, and 150 degrees, etc., we said these obtuse angles can be constructed by the process of addition or subtraction. For example, 120 degrees, we said, is equal to 180 minus 60 degrees. When we constructed 160 degrees, when we constructed 60 degrees, as in this case, when this was said to be 60 degrees, we got the obtuse angle to be 120 degrees. So while constructing angle 60 degrees, the obtuse angle you get at the other side is said to be 120 degrees. Also, angle 135 degrees, for us to get angle 135 degrees, when you construct angle 45 degrees, if this is 45 degrees, the obtuse angle you get at the other side is said to be 135 degrees for same reasons. For 180 minus 45 is said to be 135. And also, when you bisect 60 degrees to get 30 degrees, the obtuse angle you get at the other end is said to be 150 degrees. So this is how you can get all the special angles as required. Kindly like my videos as you watch. While I recommend that you subscribe to my channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. While I recommend you share the link with your friends and families so that they can also benefit from our daily classes. That brings us to the end of today's class on basic geometrical construction. In today's class, we have been able to carry out basic geometrical constructions. We have been able to bisect any given line segment that I have taught you. We have also been able to construct given angles, including special angles. We have been able to construct equivalent angles. In our next class, we shall look at the fifth objective, which says we should construct triangles given the required condition. So out of the 5 objectives, we have been able to meet 4 objectives at the end of today's class. Kindly like my videos as you watch. While I recommend that you subscribe to my channel if you are yet to do so, also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. While I recommend you share the link with your friends and families so that you can also benefit from our daily classes. Thank you for being attentive to this class. See you tomorrow in our next class where we shall be treating triangles. Thank you and do have a nice day.